Good evening all, and welcome to tonight's TI Technology webinar hosted by Texas Instruments Australia. We are really excited to bring you Mathematical Methods, Choosing Your Relations with Melissa Horrigan and Shelley Cross. My name is John Bayman, and I am your host for this event. I teach mathematics to Year 7 to 12 students at the Lachlan Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And I'm excited, very excited to introduce our first panelist for this evening, Miss Melissa Horrigan. Good evening, Melissa.
Hi, John. How are you?
I'm great, thank you. And obviously you are in Queensland there. Is it nice weather with you too?
Oh, beautiful here. I think we had about 25 degrees today. It was lovely.
Yeah, well, we won't tell the Victorians that. We'll keep it quiet. Oh, we just have. Melissa certainly walks the talk when it comes to using TI technology, having followed the development from using the TI-82 through to today's TI-84 CE, and she currently uses a TI Nspire along with a Navigator system in her classroom. This gives her a deep knowledge of the use of technology and first-hand experience of applying this and maximizing her students' learning. Melissa is also keen on investigating ways to apply the flipped classroom pedagogy in her classroom. So, Melissa, thank you very much for joining us this evening.
Happy to be here.
And our second panelist this evening is Miss Shelley Cross. Good evening, Shelley.
Hi there, John.
I was reading your bio, Shelley, and I was thinking, my goodness, how do you find time to do anything else?
I probably don't.
It certainly is an impressive bio, and like I said, I've seen you present both in Australia and overseas, and I'm very jealous of your Masters in Education, so well done.
Thanks very much.
That is enough from me. Shelley, Mel, I'll pass over to you, and we look forward to learning what you're going to share with us this evening.
Excellent. Thanks very much for that, John. Just sharing my screen, and we should all see the start of my presentation. Thank you very much, everybody, for joining us tonight. So Shelley and I are looking at the new Queensland mathematical methods, and in particular the unit on relations and functions, which is unit 1, topic 2. So the description for tonight's webinar was, as we all know, you can choose your friends, but you can't choose your relations, which is totally true in terms of family, but not true at all when it comes to the TI Nspire. So what we're going to be looking at tonight, we're splitting into two parts here. So I'm going to look at the first part, or run the first part of the webinar, and that's looking at what can be done on the TI Nspire. So looking at the features of the TI Nspire to see just what we can do within our Maths Methods classroom, but also in our Year 10 Advanced or Year 10 classroom. And then in the second half of the session, Shelley is going to be looking at some applications that are ready to go and use in your classroom. So you may wish to use these straight up tomorrow morning in your classroom. So if you've got any questions or anything, as John said, send them through, and we will do our best to answer those questions and take you on a tour of using the TI Nspire for functions and relations. So what I did to prepare for this webinar tonight is to actually have a look at the Queensland curriculum. Now, there's been a lot of talk, we know with the Queensland curriculum that we are starting Maths Methods and also specialist maths and general maths and essentials maths for next year with our Year 11 students. But I think a big thing we need to remember is we've got to make sure our Year 10s are fully prepared to go into these subjects. So I always like to look back, and as my bio said, I like to use the TI Nspire to do hands-on activities actually in all of my classrooms. So I went back through the Queensland curriculum, which we do teach the Australian curriculum maths, and in Year 10, the topic under our functions work is to explore the connections between algebraic and graphical representations. That is for functions and relations, including the circles and exponentials there using digital technology. So we need to have these calculators, whether it's the Nspire, whether it's the TI-84, we need to have calculators in the kids' hands and getting them used to it. Also in the Australian curriculum, in Year 10 or the Year 10 Advanced curriculum, is the topic Describe, Interpret and Sketch Parabolas, Hyperbolas, Circles and Exponential Functions and their Transformations. And I'm going to look a little bit at how we can do that easily with the TI Nspire. And as well as that, going into Maths Methods, Unit 1, Topic 2, it is all functions and relations. So I've cut out the bits and pieces there, and you can see there's a fair bit we need to cover in that first section. So what I want to look at is how can we use the calculators to help us do this more effectively. And also we need to make sure that we have the students well prepared for their assessment. And from the syllabus, the Queensland syllabus, I also pulled out under the assessment topic that, as it says there, it's suggested that we do a problem solving and modelling task on Unit 1, Topic 2. So it's on these functions and relations is what they suggest, and as well as that, I'm sure it will come up in exams. So we need to make sure our students are well prepared. So what I want to have a look at is where can we find functions and what functions and relations in particular are available with the TI Nspire. If you've got your calculator there, you can go into the calculator and open up a new document. And you'll see from the screen that I've got here that I have just got a graphs page there. Now I'm just going to change to my calculator. So I've got a graphs page here on the screen. And as with all of the TI Nspire, when we click on menu, we get a menu specific to that feature. So specific here to the graphs page. Now you should notice that option number 3 is our graph entry edit. And when you click on that, we can see that the first type of entry that we can do for a graph is a function, which is the basics that it came up with as soon as I went to the graphs page. It's in function mode. So our variable that we're working with is x, and we need to make sure that we write our functions in terms of x. So I can put in here 2x minus 3, and when I press enter, it's going to graph that for me. Now, a couple of things. We are able to, and it's able to be done both on the handheld, and I'm currently working on the software. So I've got open here the TI Nspire CX Navigator software. If you've got the TI Nspire CX or CX-CAS teacher software, you will see that it's set up the same way. I actually find it easier, certainly in the classroom, to be working on the software because I project this up on my screen. What we can do is, because I'm using my mouse, I can grab, and you'll see that my arrow turned to, or my cursor turned to a hand, and I'm able to move my axes around the place. Also, if I want to change my window, there's a couple of ways that I can do this. One method is to go to menu and change window and put in my window settings. Or the other option is to actually click on the 4 text items where the scale is and change them. So if you double click in there, I could change this to a maximum of 5 there, and double click and change to -5, and I now have a different scale in there. So that's just a couple of tips when you're using functions. I'm going to add a new page. I'm going to continue adding a graphs page. Again, when you add that graphs page, it does automatically go to a function, but by going menu, choice number 3, graph entry edit, and choosing relation, I can now type in any type of relation. So one of the items that we need to have a look at when we are in our Unit 1, Topic 2 is looking at graphs of relations, recognize and determine features of the graphs, And we've got here the circle function, but the next one down is y squared equals x. So what we're looking at there is like your inverse functions, or your where we focus on, instead of y equals x squared, we can write it the other way. And the good part with being able to enter relations is that as long as we are working with our x and y as our two variables, I can actually put in an x equals statement here. So I could put in x equals y squared, and it is going to graph that entire relation for me. Now, the good part about that is that instead of just working in function form where we would have had to rearrange that to y equals the square root of x, and we would have only had half the graph, we get the entire graph there. We can also put in here, and to get that entry line up again, I can just press tab. So I've now got a second relation here. I could put in here x equals 5, and it is going to draw my vertical lines for me. So in my functions, if I go to menu, entry, edit, and function, they are always the y equals. But if I want to put in another relation, x equals or y squared equals, I can choose the relation option there. So that gives us a couple of options, and we're also able to have these all on the one screen. So I'll just go back to my function from before. On this same screen here, I can go menu, entry, edit, relation, and I can put in here my x equals 6, and it didn't work. Oh, yes, it did. It helps when you actually have your window correct. Let's put my window in. As I always tell the students, always check for your windows. So I can have a relation and a function on the same screen. And so then I'm also able to go through and use the features such as point of intersection by choosing just moving my text. Okay, so by choosing intersection, it's found the point of intersection there and gives me the coordinates of my point of intersection. So I can work between my relation and my function to find those points of intersection. And I can do the same thing if I go to my second one here. Again, I can go to menu, analyze graph, and find my intersection. And it wants to know where I'm working. And I had to give, in that case, an area of where my intersection is, because remember, we've got 2 points of intersection on this one. So it's a matter of going menu, analyze graph, intersection, and at the moment it wants to know where my lower boundary is. So I'll put my lower boundary in, my upper boundary in, and I'm just using my mouse to move these, and it gives me the point of intersection. So we've still got access to the features from functions and finding points of intersection between functions, or between relations, or between relations and functions. Now, another option that I do like, and it helps with investigating things, is that when we go into menu, graph, entry, edit, there are also equation templates. So when we go into equation template, if we look at line, we can write in a line in our slope-intercept form, which is a form that we teach the students in the junior school, and we do with our linear functions at the moment in Maths B, but also with the maths methods. So this actually gives us the template to enter into. So we can go into that and actually have y equals instead of function 1 or f1 equals. So students can also be used to seeing the slope-intercept form, and vertical lines can be put in this way, or you can actually have lines in standard form. So we could actually get students to investigate, what is the line going to look like in slope-intercept form? What is the line going to look like in standard form? How do we need to present it to get the same line? Okay, so the templates work really well there. So if I put in here 2x, and I'll put in 1y and a 0 there, y is, am I ending up with 2 different lines there? We can do some investigation there. So there's lots of ways that we can have students investigating the different types of functions and relations. What I also like in this one, we've got parabolas there, and Shelley is actually going to be looking at using parabolas, but in particular, we need to be looking at transformation form. So by having it in vertex form, we actually have it ready for the students to be investigating. As well as that, or something that we probably do need to be aware of is, I know with the formula sheet, I think we're using a outside of x minus b squared plus c. So we may just have to alert students to the fact that sometimes you'll see it with h and k, other times you will see it with a, b and c as the unknowns in there. So it's about getting them used to that sort of thing. The circles one is another one where we can use the center and the radius form, or the standard form, so we can have students looking at that. And ellipses, I know we don't strictly do ellipses in the syllabus, but I actually have an activity that I like to run with students, and I've got it up here. I took it straight from the TI website, from the American TI website, called Elliptical Orbit. And to do a bit of STEM work, to link our science and our maths, what I really like about this is they've just placed a picture in behind here, and you can go through with the students and actually come up with the equation for this outside ellipse for the planet's orbit. And then what you can do is have the students try to work out the inside ones. And the good part about that, with getting activities off the TI website, is that you also can get the actual activity worksheet already written. And I've had students from grade 5 and 6 work through this activity. It takes a bit more for them to understand, but it leads them through step by step. And I've had students in grade 10 work through this activity. So it's, when we're talking about transformations, even though we don't strictly have to do ellipses, it's a good activity to look at because it is working with the center and the transformations as such. So I actually really like that activity for something to do, and it just makes it a bit more realistic. Instead of here's an ellipse and let's find the equation of it, well, our planets actually rotate around the sun or travel around the sun following paths very close to ellipses. So let's have a look at those paths. So that's an activity there. As well, still in the entry edit, we do have the hyperbolas, okay, and what we need to have a look at with hyperbolas in terms of the two types of hyperbolas. So you've either got your vertical or you've got your horizontal hyperbolas there. Now, a question did come up just a moment ago about how to do the trace. So what you are able to do is when you have a function, I'll just go out of that for a minute. When we have a function or a relation, okay, we are actually able to do a graph trace So when you click on menu, go down to option 5 is trace and graph trace. It wants to know the relation or the function that you're working with first of all, and then it's a matter of using your right-hand arrow, you can trace along and you will see that you get the coordinates as you trace along, or you can travel to the left and go back along the relation there, the graph there. In terms of your parabolas and your circles and ellipses being traced out as a focus and directrix, I wasn't planning on going into that in this particular session, but we can have a look at that as well, because you are able to work through that process. Just because of time constraints, I will leave that one for the moment, but I can send some information with the end of the session on how you can look at that. So hopefully I have given you a bit of an outline there of where we can find the information. So just very briefly, it's on your graphs page. Something that I also have to remind my students a lot about is, rather than using in their calculator, I'll just go back to my calculator screen, rather than using their scratch pad and going into graphs, I much rather, and I say to my students all the time, that we are going to start a new document. And I'm trying to get my students a lot more to use the documents, because we can link the pages together. And what you are also able to do in terms of with relations as well, your graph entry edit, not so much in this one, but scatter plots, is you can have the data in your lists and spreadsheets page and use scatter plot to bring that data into your graphs page, so you can also look at matching functions and relations to a set of points. And I think that becomes very powerful, whereas if students are using their scratch pad, there's not quite the opportunities to link. So I think we need to make sure that we are regularly reminding students to be opening documents where they can also save the documents to refer back to later, as opposed to going into scratch pad. So basically I went through all of this information with regards to functions, relations and templates, and this PowerPoint I have made it available to John, who's hosting tonight, and have said that it's able to be sent out to all of the attendees, so it just gives you that link of all of the menus that are available there. That finishes the, I guess, overview of what is available there, and I'm going to hand now over to Shelley, and she's going to take us through using some of these to do a bit of an activity there.
That's great. Thanks, Mel. And yeah, hopefully we've answered some of those questions that people asked. I think you also mentioned that we could use live data capture with the listen spreadsheet page, and if we get a chance at the end, perhaps we could try and show that. But we'll just pass over to Shelley for now. Shelley, I can see your screen. It's all over to you.
Great. Thanks very much, Don. Hi, everyone. I'm going to take us through a couple of activities, both of which can be used with your 10 Advanced and your 11 Math methods. But the first one you'll see as we work through it obviously works a little bit better with your 10 Advanced, but it's a great lead into what we might do with your 11 Math methods. So just a brief overview, which Mel did discuss. In your 10 Advanced, we really are describing, interpreting parabolas, hyperbolas, circles, exponential functions, and their transformations. Whereas in Math methods, we're looking quite a lot more at the variety of general equations that can describe the functions. So in our first task, our task is to design a luggage tag to identify your luggage on your next trip. Using the functions investigated in class, your design must fit into a circle with a center of the origin radius of 10. So this starts out by establishing a need or a problem being you don't want to lose your luggage, and then the problem-solving task was really to create a solution that's unique to each individual student so that each luggage tag actually looks different. That just gives the task some open-endedness as well as the context of solving a problem. So what we're going to do is we're going to step through a couple of these things. So you'll use some of the graphs and relations that Mel has alluded to already. So we'll just go through and we'll set up a document and practice how this whole idea of developing the luggage tag works. So starting with your calculator, let's start with the graphs page. So what I'm going to do is flip over to the calculator screen now. There we go. So we're going to start with a new document and the graphs page. So the first thing we need to do is enter our circle with a radius of 10. So we can't enter the circle from the function screen. So we're going to do menu, number 3, graph entry edit, and we're going to use relation. So hopefully you're following along on your calculators as we go through this. So our circle has a center of the origin, so x squared plus y squared equals 100 with a radius of 10, and enter to show the circle. Now, what we've got here is a circle that doesn't quite fit on the screen. So the first thing we need to do is adjust the domain. So Mel showed that to you a bit earlier. Double click on the extremity on the left. We might change that to -15. We need to click on the one on the right, but this label is in the way, so I'm just going to move the label out the way. Double click on the 10 at the top end of the x-axis and change that to 15. So once I push, oh, this one didn't change. There we go, -15. Once I enter, it doesn't look like a circle anymore. So we need to zoom square so that this actually still looks like a circle. So there's a couple of zoom options in the zoom menu. Zoom fit and zoom square, generally the kids don't use a whole, or probably shouldn't use much of. It's better for them to think about their window. But in this case, because we want it to actually look like a circle, we're going to go menu, window, and zoom square. Once we've done that, here we have our circle, center of the origin, and radius of 10. I would say, are we all there yet? But that wouldn't really be possible to know. So we'll continue. Once you've got our circle, the idea is to make a unique bag tag. So a good suggestion for the students is to write their initials using some graphs. In order to write their initials using graphs, they need to identify certain points within the circle that are going to be key points in the graphs that they're going to be using. We could put a grid at the back of the screen and just estimate looking at the grid, but putting points within the circle is probably a little more accurate, and it also gives the students a good visual of where they want the points to go. So my first name is Shelley, so I'll be trying to make an S. So I'll try and put points to resemble an S in the middle of the screen. So I'm going to do that using the points menu. So we're going to go to menu. We'll use the geometry menu, points and lines. And we don't want point on, because point on adheres to a function or a relation. We just want to put some points within the circle. Once I've got the point menu there, I'm just going to click and put where I want the points to go. So I'm going to try and just visually place the points where I think they should go. So I'll have one there. I'll have another one here. So I'm tracing around the top of the S. Then we might come down here. So each time you want a point, you just simply move the point to the spot you want it and click. And this works exactly the same on the calculator. The trick at this point, when you've finished with the point menu, is to actually get rid of it. Now you'll see in the top left, this point menu is activated, so we need to get rid of this point tool, and we're going to do that by hitting escape. Once I hit escape, I've basically released the point tool, and I now have the points on my screen. It's all very well having these points on the screen, but we need to know what the coordinates are. So we will now go to the coordinates tool and put the coordinates on select points. So the points that I think I want to start with are these two here. I might make them red so that I can see which ones they are. So I'm just going to right click on the point, color, it says line color, but it also means point color, and I'll change that one to red. And on this one here, I'm going to right click, color, line color, change that to red. On the handheld, the way that you change the color is you use the document menu. So we hit documents or doc. Number 2 is edit. And number 7 is color. So if you choose doc, 2 for edit, 7 for color, line color, select the line color that you want. So I selected red, so use the touchpad just to slide around, select the red, and then tap that point red. Oh, you might have had to select it first. There we go. So select it first, points, edit, color, line color, and red. So that should enable us to identify which points we're using. So I'm going to use these 2 points, and I'm going to use a quadratic function to model these points. Oh, I don't know what the coordinates are yet, so I need to put the coordinates on. So in order to identify the coordinates of these points, I'm going to do menu, actions, and number 8, which is coordinates and equations. Now you'll see that I've got the coordinates and equations tool activated. So I click on the point I want the coordinates for. So click once on the point and once to place it on the desktop as such. Once on the point and once to place it in the screen. So those are the only 2 points I need at the moment. So I'm not going to work out the coordinates of any other points. So I'll escape to get rid of that tool. Now looking at these points, I might decide that they're not exactly the right points I want. I might want to change this point to make it a little more exact. So let's say I'd prefer to have -2, 4 at this spot. The way I can change this point is double click on the X coordinate, change that to -2, and you'll see the point moved slightly. Double click on the Y coordinate, change that to 4. So now I've made that point, I've moved it over a little bit, and it will simplify my calculation a little bit. My other point is fine where it is. I could change that, or I could leave it as it is. So I'm going to look for a parabola now, or a quadratic function that would model those 2 points. As Mel said, there's a PowerPoint. I'll just flip back to the PowerPoint. So what we've done here is we've entered the function. We've zoomed squared to make it a circle. We've added some points into the circle. We've worked out what the points were. My points were a little bit different. That doesn't matter. And our first goal now would be to use this formula, which is one of the ones we use in Year 11 Maths Methods, and work out using turning point form, work out the model that, the equation that models this line. So substitute, so my turning point here was -4.7 to 5.75. Substitute that into turning point form. Substitute my other point, which was -2, 4. and solve for A. Once I've done that, I can draw that graph using the relation tool across the top of my data points that I've put onto my my luggage tag. Let's go back to this. So I'll just change these points just for the sake of finishing this part of the activity. So that was negative 4.72 and 5.75. And that point's clearly in the wrong place, so we might just move that one in a bit. Right, so what we need to do now is put the data points over the top of these, the model over the top of these data points. So I'll hit Tab to bring up my relation entry bar. My model is y equals negative 0.24. X plus 4.72 plus 5.75. Right, so there's my model. We might move these ones out a bit. Right, so this model looks like it fits over the data points quite nicely. So this is thinking about this as a luggage tag that we might do with year 10 students. We certainly would look at turning point form with year 10 students. They should be able to identify the turning point, substitute into the equation, and solve for A by substituting one other point. We now need to restrict the domain of this function, so because bearing in mind we're trying to make someone's initials, so we need to restrict the domain so that it doesn't just look like a bunch of random graphs. So I might restrict the domain for this from negative 4.72 to minus 2. So that's really the only section of this function that I want to use in my bag tag model. In order to do that, I need to tab and up arrow, which takes me back to my function entry bar, relation entry bar. And to restrict the domain, I'm going to use the such that mathematical notation. So I'll do control and equals. Use the arrows to move around the menu that's popped up. I want to use such that, so I want to view this relation such that minus 4.72 is the smallest value in the domain. And again, control equals to get the less than or equal to sign. X, control equals again less than or equal to, and minus 2 was the upper end of my domain. So now I have restricted the domain of that function and can see that this part of the function is modeling the S of my name. So remembering that this activity was to create a unique bag tag for luggage using functions, so each student would have individualized functions and be able to decide on which data points they chose to use, as well as restricting the domain. So there's quite a lot of mathematics in that, especially for year 10, but in the year 10 advanced syllabus, this really is probably where we need to be going to with them. They could try some alternate functions and decide if this is possibly the best one for those data points, but at your 10 level, this is probably almost enough mathematics for a modeling and problem solving task. By the time they've finished all of the initials of the person, there's quite a lot of functions that they would have explored through that. All right, so we'll go back there. So the second task that I'm going to walk you through today, hope I'm not going too fast, John, uses a photo. Now, this task, both of these tasks could be used with either 10 Advanced or Year 11 Math Methods, as I said earlier. But this task has got a slightly increased level of complexity because we're trying to take a photo, use data points to create a model that's a number of models that can track either the outline of the photo or an image in the photo or something like that. The nice thing is it's open-ended, so everyone's photo is different and students have to basically base their logo that they're designing on a photo, so it will be easy to see that everybody's response should be individualized. If you were using this as a modeling and problem-solving task, but it also gives the opportunity, because we're using more data points, to do a variety of regression analyses to see which model might fit a particular section of the logo better. Right, so we're going to insert an image in this case. So let's go back to our software. So we're going to start a new document. So let's go new document. You can save your old one if you'd like to. I don't need it. And we're going to add a graphs page. Now, in our graphs page, the first thing we need to do is insert the photo. In order to insert the photo, we're going to use the insert menu right at the very top of the software. And the photo that you want to insert needs to be possibly somewhere easily accessible for you. So we're inserting an image, and I have my image there. So it goes straight to, I've gone straight to my desktop where my image is, and I'll open it.
And Shelley?
Yes.
It's fantastic how clear that image is, isn't it? Like, I know that we sort of take it for granted on mobile phones how images should be, but using that on the software and also on the handheld, it's really great for students to be able to use that and have something so clear.
Yeah, it's excellent. This image I've picked is, well, I was wondering what image to use, and I have a calendar with combis on, so that's why I picked this one. But it's really easy for them to get a photo into the software. I would definitely be recommending, as every student who buys the calculator gets a license for the software, that they certainly don't throw that little piece of paper which says do not discard away, because the software really does make a huge difference for students when they're working on problem-solving tasks.
Yeah, and equally, if obviously you had Navigator as well, you could send those images out really quickly to all the handhelds, couldn't you?
Oh, totally, yep, yep. So this kind of activity, I mean, you could do it as a problem-solving task or a class activity. If you were doing a class activity, the Nike ticks are probably a good one to start with. McDonald's arches are also a pretty good image to start with. So what we're going to do here is, well, you can see that my axes are exactly as they were, the default axes for the TI Nspire. I actually would like the X and the Y axis to be on the bottom left corner. So I can select the photo and move it around, but it's probably easier just to move the axes. So grab hold of the axes and just drag with the hand. So at this point I can, here's my axes, I can decide whether I want to change the axis. I might want to make this 20, so I can manipulate the axis however I like. Not sure what that value was. Let's make that 12. So the object of this task is to develop equations that can model different sections of the photo. Let's just go back here. So I thought that it could be a personalized number plate icon. You know, personalized number plates have got little icons sometimes on them. So the picture needs to be significant if it was a problem-solving task due to the student's interests or place of residence. So just to create some sort of context for the problem. So the first thing we need to do here is insert some points. So we'll do the same thing that we did earlier. So we'll use the point tool, menu, geometry, points and lines, and point. So put a few points along one of the lines in the image. Once you put the points down, get rid of the point tool. We could now put the coordinates on these points, so actions, coordinates and equations. So the nice thing is once the coordinate tool is there, simply click on the point, click once to put the point down. So you don't have to access the tool more than once. While you've got the tool, you can pinpoint as many points as you like. So with this activity, what we would probably do with these points next, there's two ways you could go about this. At this point, students could develop the model that they wanted to use to track these points. The other thing they would need to do is connect these points and put them into a list and spreadsheets page. So getting the points into a list and spreadsheets page, we've got the list and spreadsheets page here. Get the points, copy the points across into a list and spreadsheets page. And from that point, once the moment, once the points are in list and spreadsheets, a number of different regression analyses could be done to identify which model suits the points best. I'm going to go back to the PowerPoint. There we go. So here's the points tool. At year 11 level, we'd probably want them to try a couple of models to build a couple of models. Once they'd built a couple of models, they could put the models over the data points to visually inspect which one worked better, enter the points into a list and spreadsheets table, and use regression analysis to analyze which would best suit the data. One thing about this activity is my picture's obviously not the best one to be using, because if I wanted to how much detail am I going to put into my logo? Logos generally have an outline, and the outline of this shape may not be enough to make it identifiable. So it is a good point to consider what picture you're actually putting in order to create your logo. Right, so
Shelley, I think that
pretty
also
much takes us there. Yep. Yes, John?
Sorry. I was going to say, I know in the Northern Territory when we do our investigations in year 11 and 12, there's a part of the rubric that talks about limitations and assumptions. And obviously a nice thing that the students could talk about with your photo is the angle that it's taken at. Obviously wouldn't be a true representation of that curve, because obviously it's not square on. There's nothing wrong with using the photo, but it's a really nice adaptation for students to think about and to consider.
Yes, and I think the nice thing about all of these activities is it gives a lot of opportunity for restricting the domain, which really allows them to discuss that this particular equation best models the curve for this particular domain. So it does bring up a lot of discussion on the domain and how the domain creates a limitation in the model.
Yeah, and when you were on your first task, it made me think of one that I've done with students in the past where we create a roller coaster ride, and they have to use different curves and different equations to link it all together, and so that's realistic to be a roller coaster ride, and that the gradients, obviously this is more for year 12, but the gradients actually match where the two curves pass on from one to the other, and that links nicely with that task one that you were talking about as well.
Yeah, absolutely. I think the difference between the two is the first task is very much driven by the points you choose, which does make it, I mean, it's fairly complex for year 10, but it does make it a bit easier to actually model a curve that's pre-existing that you have to find a model to suit is a little more complex, which in the picture that certainly does draw that out of the students.
Great. Well, thank you very much. And so I hope everyone who's been watching has found it useful and has actually got some ideas, like Mel said at the very start, that you can actually start using in your class tomorrow. And we'll start wrapping things up. If you do have any more questions as we start to finish, please send those through. I would just mention that Mel was talking about the activities. I did send you a link to one of the activities on the American site. We've got the TI Australia site here in the top right-hand corner. Don't forget, we can also go to all the PD that we were looking at earlier. There are the senior curriculum for inspirations for the 84, but also the Australian curriculum inspired, where there's tons of activities already produced for you that you can actually access and make your life a lot easier. It makes things easier not having to recreate them all the time. So I can just show you a few of those quickly. And again, here, if we went to Queensland, we can see all the topics that both Shelley and Mel were talking about today.
And we are in the process as well, John. Sorry, we are in the process of adding more activities to the Queensland Inspire website there. Shelley and myself, as well as Rodney Anderson here in Queensland, who have been working on that, and we will continue to add more activities under the topics of methods and specialists there for both Year 11 and we're actually going to change it from saying methods Year 11 to being methods Unit 1, Unit 2, and methods Unit 3, Unit 4. So that is a work in progress, that website, as it is for all the states there.
Fantastic. And that's right. And I think what's really powerful about it is that it's activities created by teachers. And I think that we can't underestimate that it's not something that you know, somebody who's creating a textbook's doing. It's actually classroom teachers who are actually using it. They've used it with their students, and they're just sharing it, willing to share it. And I think that's really, so thank you for all that stuff that you've done in Queensland, both you and with Rodney, like you said. And it links really nicely with this image you can see here of two of the activities. I was in the chat talking to one person about the automated data capture that you can do. You can see that actually happening here. And also somebody else mentioned about using sliders, and you can see that actually happening in this second one here, the sliders. So if you would like to know more about those things, if you don't know about them already, then you can go to the professional development page, and then on the webinars, you've got the upcoming webinars which you are already aware of, but also the on-demand, and like tonight's one will also be available for you to re-watch if there's something that you missed and that you would like to watch again, or equally share with your peers. We can also then convert that to the American site. There may be a few more things. Most of the stuff that's relevant to the Australia site we bring across onto the Australia site, but there may be a few things there. And again, to find this activity that Mel talked about, that I did send you the link to, all I did was go into activities, and then all activities, and then choose all activities, and then just do a search at the top here for elliptical that Mel was talking about, and that brought me straight to that document there. So you can see that it has PDF for both the teacher, some nice answers there, and for the students, and the TNS file, which students can either download onto their calculators, like Shelley was talking about, or you can pass it out via Navigator, or just share it between handhelds. So there's many different ways that that can get shared out. And as you can see, I think before I typed that word in, let's see if we can go back, we can see that there's nearly 6,000 activities. You know, it's crazy how much is there for everyone to access. So please check that out as well, both the Australia site, and if you need some more more depth, if there are other options, something more specific you're after, please check out the American site as well. Okay, so thank you, Mel, and thank you, Shelley, for everything you've done there. Are there any questions that are coming in that people have asked, ladies?
I have answered a couple of questions that I sent out to all participants there, and I sent another link to an activity on the focus and directrix, if I pronounce this correctly, Alariza. There have been other webinars and other activities. I just can't think of the exact links for them at the moment, still doing searches. But if you search the way that John just said, you can find activities on there. And I did also answer about the dilation factor. Unfortunately, the live capture, we are restricted on time, but there have been webinars that have looked at that as well. So if you go through the on-demand, you'd be able to get those ones.
just very, very quickly in terms of the automated steps. I have just done it here. This is just looking at it for calculus. I've just put a cubic in. I've chosen a point like Shelley showed you, and I've linked that to a variable. I also come up with a tangent equation and also the slope of that tangent separately and link that to a variable. And then in here use data capture, automatic data capture. So it then plots that point, which is the gradient and x value, and as we move that, we can see that it actually creates a quadratic. So that's a really nice little feature, and what that's actually done is dropped all those points into there. Huge amounts of data in almost no time, which is fantastic. Makes our life, everyone's life, a lot easier. So thanks for that, Mel. Okay, so please, after this, when you leave tonight's webinar, there will be a brief survey that will automatically appear in your browser. Your feedback does guide us as we plan for future online events, as Mel inferred. So please, we do hope you share your thoughts with us in this post-webinar survey. Your certificates of attendance will be emailed to you in the next 48 hours, along with a link to the on-demand and YouTube versions of the recordings, as well as the relevant documents that Mel and Shelley talked about this evening. After we leave tonight, if you do have some post-webinar follow-up, please feel free to phone or email us. I know that TI would love to hear from you, and exactly what Mel said, if there's something particularly you're after, please just email them, and they can either put you in touch with one of us as trainers and teachers of using the technology, or they'll be able to answer those for you themselves. And sadly, that brings us to the end of tonight's webinar. Thank you very much indeed, Mel and Shelley, for sharing with us everything some examples of what you use in the class. I really appreciate it.
Happy to help. Hope everybody got something out of this tonight.
Absolutely agreed.
Thank you. And thanks everyone for joining us. We run these webinars for you, so I hope you found it useful, and we hope to see you back online again soon. So thank you very much, and bye for now.
Good night.
Good night.